All right, I have this awesome new mic, but it doesn't work yet, so let's move it out of the way. I will get that ready, though I will get that set up. I think the piece is coming tomorrow. So my audio quality will hopefully get better in the next couple of days, next couple of videos. I just recorded something really quick, or I thought it was going to be quick, and turned to be 20 minutes, but enjoy a little video on map, filter, and reduce. Hello and welcome everyone. Today I only have a couple minutes for a video, and I still want to get one video in the month of October. So I'm going to do a little video on map, filter, and reduce. Now typically you'll see map, filter, and reduce tutorials sort of like this, where I have I have an array of fruit. And I think this is more complicated than even some of them that exist. I have a name property, an available property, and I want to do manipulations on this set of fruit. But I'm going to give you a bit more of I shouldn't say a less contrived example, but a bit more detailed. Because I think the reason we use map, filter, and reduce is not in these simple, isolated examples, but in more complex examples that need to do more, data massage before we can use map, filter, and reduce properly. So let's dive right in. So this is kind of how I think about map, filter, and reduce. And I guess you can maybe take the time right now, pause the video, and see which one I'm going to be able to talk about with each of these statements. So the first one's kind of, relatively straightforward. How do I filter something? Well, we're going to use filter. That's going to be the operation. We're going to use a dot filter operator, if I could spell it, to filter something. The second one's a bit more mysterious. How do I transform something? Transform for me is using a map. And we'll go through each of these examples and I can explain them. So when I transform something, you can kind of ask yourself, do I need to transform something in this set of elements in this array? I'm going to use .map to do that transformation. And this one's a bit more contrived here. How do I get X? How do I get something from my list? Or how do I get something from something else? And this typically is a reduce. If I want to get some value that currently doesn't exist on a list of something, I'll more than likely be wanting to use reduce. Or possibly a combination of all three, which is what we'll take a look at. So these are kind of the questions you want to ask yourself. If I see a list, if I want to know how do I filter it, or how do I take away elements or get elements out of it, filter. If I want to know, I have a list of items, how do I transform each of those list of items? We're going to use a .map. And then if I want to reduce somehow, if I want to take some list and get something else out of it, I want to use reduce. Okay, let's get into some practical examples. So here we have that original fruit list that we saw at the beginning. We have a name, and we have whether or not that fruit is available as a Boolean, true or false. And we have three of them. So we have apples, bananas, and pears. Apples are available, bananas are not available, and pears are available. So let's go through and ask ourselves some of these questions really simply. How do I filter out available fruit? So we have that fruit list. And I want to say, how do I filter? So we're now going to use filter. So for each fruit, we have these two properties. I'll call this a fruit. I can't use fruit too many times like that. I'll destructure it. Name and available. And then filter, it should allow us to take in some sort of predicate, which is also known as this function, and it returns a Boolean. So what we want to know is the fruit available. So we'll say return if it's available. And this will give us our list of available fruit. And I should console.log that just to see if we can run this. And oops, I might have to save them. Be right back. I'm going to save all these files. Okay, we're back. Here we go. I console log this, and I save this file so that we can go and actually run it. So filtering out available fruit, fruit.filter, our list, we want to filter it, use the filter operator. It takes a predicate or just a function that returns a Boolean. We know that available is a Boolean, so we can just return whether they're available or not. So let's run that. Run with node fruit example 1, and boom, we get apples and pears because they are available. Now, of course, if we wanted to say which ones are not available, we can just put not available and get the inverse, which is only bananas. Great, so really simple example. You're like, yeah, I can grasp that, no problem. Let's just finish up the operators and then we'll jump into something that's more complex, which I think is more real life. So capitalizing each fruit, we want to transform them. We want to transform the name of each fruit to be capitalized. So let's go ahead and do a console log here. We can print out the result, which means we want to use our map operator because we're going to be transforming. So each fruit, we want to go through and we want to say, get me the name and capitalize the name. So we can do string like this, handy string interpolation name dot substring. We want to get everything from the first character onward. and exactly the first character, char at 0.2 uppercase. Now, I could have got that wrong, so we can check it out. So go through each one with a map and return the modified or transformed object. Now, if we wanted to maintain the object structure, we could pass in available as well and just return that object out like this, name, and pass in available. But I think for now, we're just going to give it the name so we can keep it a bit more simple. Good, so let's run that. There we go, apple, banana, and pear with capitalized letters as opposed to where they started out with lowercase letters. So map, I was able to go through, take some object and transform it to return a different version of that object. Good, okay, last one. How can I tell if all the fruits are available? So I take this list, I have a huge long list of fruits. How do I know if they're all available, if we have stock for every single one? We're going to use reduce because we want to get a single Boolean out of an entire list. So fruit.reduce. Now we're going to reduce it. We'll have two properties in this first function, which are going to be the carryover from every other one. So has all will be my Boolean because we're going to get a Boolean out. And we have the item that we're iterating over, which will be the fruit. And I'm just going to destructure it yet again, and I only need available this time. I don't really care too much about the name. I'm also going to start this off with a default value of true. Otherwise, this default value here would be undefined or false, which won't work out if we're trying to get whether they're all available or not. And we have to think about, okay, what does it mean for them to all be available? It means that available has to be true every single time, which means that we can go in here and return has all. So if we already have everything, and if the current one is available. And we'll keep iterating over and saying, if everything in the past that we've looked at is available, and the current one's available, then currently up to the point we're iterating, they're all available. So we can look through, run that example, and it's going to say false because banana is false. And the way and works, as soon as you have one false, it will be false. And you can think about this if we think about reduce, because this is getting slightly more complicated. It's just saying I have three elements, element 1, element 2, element 3, and each one of those has a value of true or false. So in our case, we have true, false. My goodness, I can't type. True. And we're just going to go and say and these all together. So we can do this with the for loop as well, but reduce works out similarly, and it gives us a bit more concise code to write. Good, so there's three examples, very simplistic. I have this list that's very well made for looping over and doing map, doing a reduce, doing a filter. But how do we work with more realistic data? Because we don't always get nice lists like this that allow us to very simply go through and do these manipulations. This list was designed almost for these type of manipulations. Let's take a look at another example that's a slightly more realistic. Okay, so here's a little bit more realistic example. We have this object of fruit, and I want to be able to do manipulations on this object of fruit, just like we did before with this list of fruit. We have this list of fruit. I want to be able to do the same type of manipulations. Are they all available? Can I capitalize the first letter, and then can I do some reductions on them, maybe to get and see if they're all available? But I have this object, and we can't do reduce, we can't do map on this object. We also don't have nice properties like is there available? We don't know. All we have is cost per unit, weight per unit, some sort of measurement unit, and a unit number, or PLU, product unit number. So how am I going to go about doing the same operations? And this is where coming in and understanding map, filter, and reduce, and understanding how to manipulate data types is going to be extremely valuable. So let's just close these up so we don't necessarily look. We have another property over here, another object called inventory. And inventory will link our fruits to how much of those fruit is available. Now this is again a contrived example. Your data could be more spread out. It could be more complex, but this is kind of just a slightly more elevated example to the one before, which was having our array made for the example we're trying to do. So we have this inventory. It lists per PLU, per product number, the deliveries we've had for those product numbers. So it doesn't take into account any sales, but what it's going to calculate as if there has been no sales. So the product will take the delivery, and it's all delivered by weight. So whatever PLU this is, 1225, it had delivery weight of 150. And we don't even know the unit at this point because we don't really know what fruit this is. We don't even know how this fruit is measured. So that's there. We have 133 with a couple of these. You might notice this Chiquita. I don't know if I spelled it correctly, but be able to tell what 1333 would be. It's got some delivery rate of 2,000 and 1,000. And we have this one at the end, a 2475, which is an empty list. So the best thing we want to do is we want to say, how do I filter out available fruits, and how do I know how much fruit is available? These are the similar questions to what we're asking over here. How do I filter out available fruit? And this one here is, how do I know if they're all available? So similar questions, but we can't really go through it like this with this array and like figure out those questions because we don't have this format. We don't have, are they available or not? We don't have that with this object. So the point of map filter and reduce, or one of the big points of map filter and reduce, which will help you kind of elevate the usage, would be, how do I take data like this, a big mess, multiple data structures, it's all spread out, units I may not care about, and how do I reduce it to this? How do I get it into a shape that I can use it to answer those questions a bit simpler? So that's what we want to do in this last example. And this, I think, is a more realistic use case of how we use map filter and reduce. So let's talk about filter. Let's filter out if the fruit are available. Okay, great. So I have this object. How do I even do a filter? Because I can't do object.filter. I can, and our object right now is fruit. I can't do fruit.filter because it's an object. We can try. We'll just say filter true. Let's run that. Node fruit example 2. Fruit.filter is not a function because it's an object. Now there's simple ways of getting around this, which is lovely, but we have to make a decision. So we can do a couple things. Objects have the ability to get, whoopsies, a list from them with some object.properties. We can say object.values, which is going to go and return us a list of every value. So this object here, this object here, and this object here. These are the values. So if we say object.values and then filter true, let's just console log that. Filter true is just a useless operation. It's going to return the same list. So we do this, and we see it just gave us an array of each of those values. And we can say object.keys. Maybe you've already thought or used this before, and you're like, keys, I know what it's going to do. It'll return us just the names. Apple, banana, pears. I put pears, it should be apple, banana, pear. Let's fix that. Pear. Apple, banana, pear. There we go. There's another one as well called values. So if we do care about having, sorry, not values, entries. If we do care about having both the keys and these values, because as you notice, the values don't contain the English name for them, we might want to use entries. Now, entries puts them in these like silly arrays here, right? We have or maybe we want to call them tuples. You have an entry at the beginning or index at 0, which is the key, and the index at 1, which is the value. We can actually use map here. Let's use a map to make that something a bit more readable for us. So we get in this array, and I'm going to destructure it. We have the key. In our case, we know that's the fruit name. And we have the value, which is this big object of a bunch of different properties. And what we'll want to return out of this is maybe a new object with that name and the rest of those values. So just kind of combine the two of them. That way we can read this object a bit nicer. There we go. So now we have an array of this object with name and a bunch of other properties that we have in here. And this is starting to look a bit more like this fruit array that we have here. We have our name now inside of that object, where originally we were operating this way and we didn't have those names. So I manipulated using map. I manipulated that original object into something that looks more similar to what we're used to working with in terms of our filter maps and reduces. But we still don't have this available. And available is a slightly more complex operation because we don't really have any, we have like the amount of cost per unit, we have the amount of weight per unit, we have a measurement per unit, but we don't really have an actual amount of units. All we have is this PLU, or this unit number, that we can try and get from our inventory. This is where it gets like, now we have to combine two data structures in order to perform more operations like reduce and map and filter. So what I think we'll do is we can take our PLUs and we can replace them with this inventory. So that's one way of doing it. So inside of this map, we can either do it in here, or we can just chain another map onto here. So now we have this object of name, PLU, and a bunch of other fields, but we're just going to take those two. We're just going to take PLU because that's all we really need. Actually, if we want to combine them, we're going to need the whole thing. So we call this a fruit. And what we can say in here is I want to return a new object of whatever that fruit object is, plus the inventory. So I can create a new object in here that contains the inventory. But how do I get the inventory? Well, I have that inventory object. Just comment this out here. This inventory object up here. And it's an object keyed by the PLU. So that's going to be able to go in here, say go to get the inventory, and go and get it at my fruit.plu. So I can go and now combine two of these objects. I can combine our original fruit object and its inventory. Let's go ahead and print that out and see what we have. Lovely. Now it's not going to show you, can expand it, but now you have inventory on top of this object. Now again, we're getting closer to this. We still don't have, are they available or not? But now that we have the inventory tied to that fruit object, we'll be able to manipulate it a bit easier. So let's turn inventory into available. This means another map, or we could do it all in one. Actually, let's do it all in one, makes a bit more sense. When we get our inventory, what does it mean to be, no, I lied. All right, here we go. So what does it mean for a fruit to be available? It means that we have some sort of inventory, which means that if we are to do available, we have to go through our fruit.inventory, and we can pretty much, in this case, it's not too bad. We can just say how, if inventory greater than 0. Do we have any entries in that inventory? Because that'll mean it's available or not. And then how do we look at that? Boom. Interesting. Yes, okay, I made a mistake. Okay. So we look at our fruit.inventory, and in this case, we can just check if there's any deliveries, if there's any inventory whatsoever. So we'll use inventory.length greater than 0. So yeah, we just need to check the inventory, and if there's any of those deliveries, so if greater than 0, if there's any inventory whatsoever, then it's going to be available. So let's clear that out, run this, and here we go. So available now, true. Available for bananas, true. Available for pears, no. And that's because the inventory is empty for pears, although we have some inventory for apples and bananas. Good, so you see, like, I've chained 3 maps. Now, of course, you could combine these, so we don't have to loop over them many times. And we've made this structure. Now, there's a bunch of extra fields in there, but realistically, we've made just this structure. I have a name, and I have my available. So name and available. So using map, I was able to go through and manipulate the data or massage the data to something that I wanted. Now, what happens if we had stricter rules in this to tell if they're available? Let's say we have to have a certain number of units available in order for it to be available. So we can go look at this weight per unit. So it's 10, in this case, pounds is 1 unit of this fruit, which is apples. So you have to buy them in 10-pound bags, let's assume. And we have to have at least 4 of them in order for us to be able to sell apples. We don't have that amount, right? We don't know versus our inventory. Do we have at least 4 of these units? I'm not sure. So let's go and manipulate our inventory a little bit. Let's just say we have 2 units from Mac Farms and Greenberry Meadow. We have, let's say 4 units. So already we know that if we have this many units or this much weight, we may not be able to sell apples. Like 2 pounds and 4 pounds, that's not even, one unit of fruit. Let's look at bananas. So you need 3 pounds of bananas in order to sell one. We have 3,000, so we're plenty of poundage there. And then pears, we have none. So we should have only 1 available fruit, as opposed to just, in our case, we have 2 because we have our simpler rules of just saying, do we have deliveries? So let's go ahead and look at that. So what we might want to do instead of calculating available this way is say, I want to say the length or the number of pounds. Let's calculate the number of pounds for the fruit. Number of available pounds is going to be whatever fruit inventory, and then it'll be the sum. We have to sum up all of the entries and their total delivery weights. So we have to get one number or one value, get X, which is a number, out of this list. which is the perfect example for reduce. So I want to reduce this list to a sum of the fruits. So this is the total weight, total delivery weight from, and I'm going to just destructure this. It'll be delivery total weight. I apologize for the small screen doing all the scrolling. So here's our reduce. We're going through inventory. We're going to reduce it to get the total weight, and that's going to be the delivery total weights, and it's going to be the sum of those. So if you want to sum those up, here's a function. We're going to start at 0. Let's just save this so we can see it better. There we go. So we're going to have a function. We're going to start at 0, and all we're going to do is return the total weight so far, total weight we've calculated so far, plus the delivery total weight of an individual delivery inside of our inventory. There, so that gives us the total number of available pounds. And then we know our fruit gives us poundage per unit. So we can say, give me the total number of pounds, number of available pounds, and divide that by our fruit dot, I can't remember exactly the name, unit, weight per unit. Weight per unit. This will give us the number of available units for us to sell. So let's just print that out. And hopefully I didn't make any mistakes in that code. And see how many units we're actually able to sell. There, so apples, we can sell 0.6 of a unit, not great. Bananas, we can sell 1,000 units. And pears, we can sell 0 because there's no inventory. Perfect. And the reason this is because we calculated the total number of pounds available. And if we look back at our array here, 2,000 plus 1,000 is 3,000. And we have 2 plus 4 is 6. And we divide them by 10 for apples and 3 for bananas, which gives us our 0.6 and our divided by 10. So it's 6 divided by 10, 0.6, and then 3,000 divided by 3, which is 1,000. Now, if we want to say we have to have at least 4 units in order to sell these, or in order to have the fruit available, we can just say this amount of units we have to be able to sell is greater than 4. And this will give us our Boolean here. Do we have enough apples to sell? No. Do we have enough bananas? Yes. Enough pears? No. And then we can use our filter, just like we did before, to figure out available fruits. We calculated available fruits using some reduces, using some maps to manipulate these other data structures. And now we can go ahead and filter them out by saying, get me those available, that available flag, and return the ones that are available. And we'll print that out, and we should see just bananas because they are the only one that are available. So you can see that this example here, although contrived, it's really simplistic. It allows us to manipulate, using filter and map and simply understand how those operators work, right? Going through and filtering is just passing in what we call that predicate, which is just a function that returns a Boolean. It's simple, right? We have that available property. We can say not available, it's already a Boolean. We can just return available. But if we get into a more realistic situation where we don't have that available Boolean, we have different types of data that we can accumulate to understand what available means. We have to combine, we have to use those operators, and that's where map, filter, and reduce